What if I gave you something like this? So x squared plus 3x plus 4 equals 0, and I asked you to solve it. Now, at the moment, what is the only way that we've looked at to solve equations like this? Factorising, okay? So if I was going to try and factorise something like this, what would I be looking for? What two numbers would I look to multiply together to make and add together to make? 4 and 3, right? Because I'm looking to multiply together to make 4 and add together to make 3. And you're like, huh, okay, so I set up my brackets. What two numbers multiply together to make 4 and add together to make 3?
3 and 1.
3 and 1?
No.
4 and 1? Well, 4 times 1 makes 4, definitely, but 4 plus 1 doesn't
There
make...
are no two numbers.
It doesn't mean there's not any two numbers, it just...
That's like irrational number.
Okay, right, so there's no nice rational numbers which would fit here and here. Because usually when we try and factorise, we're looking for two, usually integers, or at least nice numbers, right? But we can't, okay? There's no numbers that I can think of which multiply together to make 4 and which add together to make 3.
Yes.
So we need to be a bit clever.
Discrimination.
Yeah, so we need to be a bit clever. Would you be happy
What are we doing?
if I was going to generalise this problem? What I'm literally doing here is taking a quadratic, okay? Now every single quadratic will follow this form. Every single quadratic will follow this form. A is just any number you like, B is also any number you like, and C is any number you like. So for example, with this quadratic up here, this is in this form because A is equal to what?
1.
Is equal to 1, right? There's a 1 hiding in the front there. What's B equal to?
3.
3. And what's C equal to?
4.
4. Give me another quadratic. Any quadratic you like. Any quadratic you like.
X squared plus 4x plus 2.
Okay? What would A be equal to?
1, 4, 2.
Good. Give me another one. Make it a bit interesting. Make it non-monic.
6 x squared.
Yeah.
Times.
Times. Let's go with plus.
10x
Okay?
minus 9.
Okay. So what would A
6
be equal
times
to?
9.
Good.
Minus 9. Negative 9.
Are you happy that every single quadratic can be written in something which looks like this? Right? Which means that I should be able to come up with a way of solving quadratics like this. Okay? And it's simply through completing the square, literally what we've just been looking at. Let's do this. Let's first of all focus on the A, B and C. Okay? Would you be happy that the thing which is making this awkward at the moment is that A, the thing out the front? So what I'm going to do is just divide everything by A. Divide everything by A. So if I divide AX squared by A, what do I get?
X.
Just x squared. If I divide bx by a, what do I get?
X
B over A.
divided
Yeah, b over a times x is fine. Okay. If I divide c by a, what do I get? And if I divide 0 by a, what do I get?
0.
Just 0. Okay. So now this looks a little bit more friendly to complete the square on, right? Because now I've got a monic quadratic. So if I'm completing the square, just remind me, which two terms am I interested in?
The first and the second.
Yeah, I'm interested in those two. In fact, just because I'm not interested in this one and I've got it set equals 0, why don't I just stick it on that side? Get it out of the way. Okay? So if I stick it on that side, would you be happy it becomes negative? See over it. Okay, good. Alright, so let's deal with this then. Completing the square. I'd say x plus, well I have to halve this, right? What's half of b over a? But what do I need to do here?
B over A squared. No, wait.
B squared over 4a squared.
Yeah.
Okay, so minus that thing squared over that thing squared. You happy with that? You happy with that? Good, okay. And then would you be happy? Would you be happy? What I could do is stick this on this side now. Because ultimately, I want to find x. I want to find what x is equal to. So, let's leave this thing on the left-hand side. Okay. If we stick that on that side, would you be happy it becomes a positive? Yeah? and then I'm going to take away c over a. Okay, no drama so far? In fact, let's look at this side. Could we write it as one fraction? Could we write this as one fraction?
Not really.
I think we could. It's awkward, but I think we could.
Multiply by, we square it and multiply.
Not quite. Effectively, I need the same denominator if I'm subtracting, right? So I'd multiply this by, sorry,
B times 2 minus 4.
Isn't it 4a squared?
Multiply A multiply
it will become that. Remember, what I'm after is the same denominator. So I want a 4a squared on the denominator of both fractions. I've got an a here, so I'd have to multiply by 4a. Okay? So I get b squared over 4a squared minus, well, that becomes 4ac over 4a squared. So far, so good?
I see what we're getting.
Good. Would you be happy as one fraction? This would just be b squared minus 4ac, all divided by 4a squared. Yeah? Happy with that? Okay. Now let's come back to this. In fact, let me write it down on this line here. Okay? That's where I'm at the moment. Remember, what I'm after is x. Okay? So how can I undo this squaring?
Square root of the other side.
Good. Now you've got to be careful here, because if I square root something that was squared, you've got to make sure to take the positive and negative root. Yeah? Because it can be both positive and negative. Think about it. If I said x squared equals 9, you'd say x equals 3 or negative 3.
Yeah.
Okay? So if I do that, I get x plus b over 2a equals, take the positive or negative square root of this right hand side. Is that okay?
Yeah.
Yeah, good. Excellent, let's create a bit of space. Alright, now let's think about this. Are you happy I can't really tidy up this numerator? Square root of b squared minus 4ac, I can't really do much with that. So at the moment, I've got x plus b over 2a, that's just the left-hand side, not doing anything there, is equal to the positive or negative square root of b squared minus 4ac, okay, all divided by, let's think about the denominator.
2a.
Yeah, if I square root 4a squared, square root 4 becomes 2, square root a squared it becomes,
Okay.
okay. What am I left to do now if I want x equals?
We move the b over to.
You happy with that? I've just literally moved it on the right hand side, okay. Do you notice I've got the same denominator, handily, so therefore I can put it over the same fraction. So I end up with negative b plus or minus square root of b squared minus 4ac all divided by 2a.
That's where it came from.
Yeah. Who in here's seen this formula before? Show me, put your hands up. Pretty much everybody. Pretty much everybody. Okay? Now this is called the quadratic formula. So basically we now have two ways of dealing with quadratics. Okay, so if I give you something like this now, if you can't factorise it, always try factorising first, right? Because factorising is quick. Okay? If that doesn't work, you now have another way of dealing with this, right?
We don't have to write all these steps, right?
No, absolutely not. So what I'm trying to say to you is that if you just want to remember that, that is totally fine. In fact, this is on the formula sheet, okay? But I wanted to link it together because some people say that when you have to deal with things like this, the quadratics, you've got factorising, you've got the quadratic formula, and you've also got completing the square. But can you see that the quadratic formula is literally just completing the square? Yeah? So I wanted to link that together, because even though the algebra is a bit hard and a bit messy, and I wouldn't necessarily expect you to derive something like this yourself, I just wanted to show you that you now have the skills to deal with stuff like this.